Right, what I've got in front of me is sketch a graph of y equals to sine x. Now I've got a graph below to help us to do that. What I'm going to do, instead of sketching, I'm going to plot it just for illustration so that you understand better what I'm doing. Right, before I do that, before I plot the graph, what I need is, I need to have a table. I need to construct a table, which I've done already here. So in my table, I'll have that as 0, 45, 90. As you can see, I'm going up in multiples of 45. Right, so this is for the x-axis. Add another 45. Add another 45. What's that? Next one, add another 45. Running that's basic, right? Add another 45. I'll fit one more in, 360. So all I've got to do now is put 0 into x. So find sine x on the calculator. So you type in sine x, sine 0 on the calculator gives you 0. Right. So I'll be plotting 0 along the corridor, 0 up the stairs. Right. 45, put the 45 in on the calculator. So if I do sine 45 on my calculator, press the SD button, I get 0.7. Right, obviously I'll get more than that, I'll get more digits, I'll get 0.707 and so on so. But if you look along the y-axis, you can see along the y-axis right here, it's going up in steps of 0.1, 0.2, 0.3, 0.4 up to 1. Alright, so I don't need to be that accurate. So sine 45 is 0.7. Sine 90 is 1. Sine 135 gives you 0.7. It's the same as sine 45. All right, sine 135 same as sine 45. Sine 180 you get 0, back to 0 again. Look at that. You can see a pattern there. Already you can see a pattern. So you got 1, and either side you got 0.7, 0.7, and either side of those you get 0 and 0. Right. Sine 225. You'll get minus 0.7. Sine 270 should get to minus 1. Sine 315, any ideas? You can see a pattern here. Yes, minus 0.7. And then finally, sine 360 takes us back to 0. Right. Now some of you, if you look at these numbers along the y-axis, the y values, you can see there is some kind of pattern. It's like a wave type of pattern, right? But if you don't see the wave, if you can't imagine the wave from those numbers, it's better to plot those coordinates and then you'll see what I'm talking about. Right, so first one, 0 along the corridor, 0 up the stairs. Change the color for that one. Right, hopefully you can see that. Right, next one, 45. 45 is roughly in the middle. It's in the middle of 0 and 90. That's a bit awkward, right? Right, how do I determine that? How many squares are there in between? Right, I'm trying to find the middle. It's 15 squares, 15 little squares. So half of 15 is 7.5. Right, poor choice of graph here, guys. 3, 4, 5, 6, 7. Right, that there is your 45. And when it's 40, sine 45 gives you 0.7. Right, this one's easy to plot. Sine 90 is 1. Right, next one, sine 135. All right, here we go again. That's 135 degrees. And that gives you what? Sine 135 is 0.7. Sine 180 is 0. Already you can see what's happened here. It's gone. It's not exactly like a straight line, is it? It sort of curves. It's like part of a roller coaster ride. All right, but we'll join them up later on, right, with a smooth curve. Right, next one. How far have I got? All right, done these. Done. Right, sine 225. 225 is there. Is what? Minus 0.7. Right there. Sine 270. Sine 270 is minus 1. Sine 315. 315 is right there. What's that? Minus 0.7. And this one's easy to plot, so 360. Right. Now what I need to do is join these up using a smooth curve. And notice I'm doing this very carefully. Right, so far so good. And obviously that carries on forever. That goes on, it goes on and on and on. Even on the other side of 0, it does carry on. So there you have it. That's y equals to sine x graph. Now, what if I said to you, if you look here, sine of 45, let's write that down. Sine of 45 is 0.7. What other value of x will give you 0.7? So sine 45, when x is 45, sine 45 is 0.7. What other value of x will give you 0.7? Now obviously you can see that from the table straight away. Right here, sine of 45 gives you 0.7, sine of 135 gives you 0.7. But you can see that due to symmetry of the graph. Right? If I show you on the graph right here, right, 45 is right here. Now if you were to draw a straight line and then to the left, right, that there, it's 0.7. Right there. What other value of x will give you the 0.7? Now, if I was to extend this line up to here, and when it touches the graph, go straight down, that's 135. There you go, 135. So sine of 135 gives you 0.7. Now, what other value of x, if you can give me another value of x, that will also give me 0.7. Now, I don't need to extend this graph any further. There's no need for that because I can already see a pattern here. That graph carries on and it carries on like a wave. Forever and ever, right? It just carries on. Now, if you look back over here, between the 0 and the 45, right? You can see when it's sine 0, it starts here at 0. Sine 360 is also 0. So this wave that I've got here, I'm just following that. I'm just tracing that wave again, carefully. Right. This wave, right, repeats itself after 360. It repeats again. So if I add on another 45 to the 360, add 45. If I just add that on, that's roughly here. That's 405. So sine 405 Right, let me do that with a straight line. Sine 405, extend it all the way, also gives you 0.7. Alright, let's just do one more. Let's suppose, let's go for sine 225. Right, sine 225. Let's suppose you're given sine 225. Now sine 225, let's say they tell you it's minus 0.7. What other value of x will give me minus 0.7? Well, let's find 225. Right, 225 is right there. Let's do it better. Right, so I would say that's 0.7, minus 0.7 rather. Minus 0.7. Right, what other value of x I'm trying to find here? What other value of x will give me minus 0.7? If I get my straight line tool again. Right, when I hit the graph stop, go up. Not surprisingly, it's going to be 315. Sine 315. Alright. So 315 is right there. When you hit the graph stop, turn left, go all the way, and that should also hit minus 0.7. So here, sine 315 gives you the minus 0.7. And obviously, there are going to be other values of x that also hit minus 0.7. Right? You just need to find the patterns along the x-axis.